Hey, what's up guys? This is the video for section 5.6 and we are going to graph linear inequalities with two variables. Actually, we're going to start with one variable, but then we'll move on to two variables. So first, let's go ahead and review what are inequalities. Inequalities are just the basic four symbols that you guys already know, and they are less than, greater than, less than or equal to, or greater than or equal to. When you guys have an inequality, linear inequality, you guys can graph it like a line, and you guys need to shade one of the sides of the line in order to show what are the solutions. So let me explain what that is, okay? I'm going to work with the graph in the middle, when you have x is less than 3. When you have, just like regular lines, when you have x by itself and there's no y, the line is going to be vertical. So you notice that you will have a vertical line on x equals 3. So on the x-axis, there's the 3. Now you notice that it is shaded on the left side. Now what this is saying, guys, and let me just read the paragraph down here. The shaded part is where are your solutions. Every time you guys look at a graph, any point on that shaded is going to be the solution. And the solution, when you have two different variables, is going to be in a point form. You have the x coordinate and the y coordinate. So look at the shading part on this side. You can choose any number. On the x-axis, you can choose a -1. If you plug in that number, -1, into x, -1 is less than 3, well, that's going to be true. And that's what we want. If you put a -1 here, -1 is less than 3, that is true. Any number that makes a true statement in this inequality is a solution. Now think about all the numbers that exist. Well, they're infinite numbers. That's why we're not going to write all the solutions, but we are going to shade to show where are my solutions. So the shaded part is my solution. Over here, if you look at this line, it's not vertical. It has a slope, it's slanted, but it is shaded on this side. So all the points on this side are solutions of this inequality, and any number that you plug in, x coordinate and the y coordinate, is going to make a true statement for that inequality. Now if you pay attention to the lines, we do have two types of lines. One of them is going to be dashed line, another one might be a solid line, just like this one on the right side of the screen. The dashed line and the solid line, it says if the solution is on the line or not on the line. So how do you know which one to use? Well, let's go ahead and look at the inequalities. If you have any inequality less than or greater than, you are going to have a dashed line. So any point on this line, since it's dashed, is not a solution. So if you, for example, this one, 1, 1. If you plug in 1 into the x and 1 into the y, it's not going to give you guys a true statement. And I'm just going to do that to show you guys. You put a 1 for the y, less than 3 times 1 minus 2. Well, you're going to get a 1 on the right, and you guys will get a 1 on the right side, and you get a 1 on the left side. So the inequality, 1 is greater than 1, false. That's why this solution, 1, 1, is not part of the point 1, 1 is not part of your solution. Anything else on the shaded part will be a solution. So this one means dashed line. If you have a less than or equal to, greater than or equal to, that's going to be a solid line, just like the one over here. And that means that any points on this line is going to be a solution for this inequality. Now we do have a fraction. My slope is -1/5. But I'm just going to pick a point, really easy point right here. This point is on the line, and I know that the coordinate is 0, 2. So if you plug in 0 for the x and 2 for the y, 0 for the x and 2 for the y, and you guys simplify the inequality, you're going to get a true statement. So that's what it means. It means when it's solid. Any points on the shading part, so you can pick this one, it's going to be a solution. It's going to give you a true statement. This one, true statement. This one, a true statement. This one here, a true statement. And I'm just going to pick one and show you guys that it will make it a true statement. So let me pick an easy one, 1, 1 again. So 1, 1 is on the shading part. So I'm just going to plug in, and I'm just going to label 1, 1 here. So I substitute a 1 for the y, less than or equal to negative 1/5 times 1 plus 2, where you get a 1 on the right. On the left side, you get a 1 on the left side of the inequality, and on the right side, we get as a decimal 1.8. So if you look at the inequality, 1 is less than or equal to 1.8. Yep, that is true. So that point is a solution. So any point that's on the shading part will be a solution. Anything that is not on the shading part, like here or the part on the top here, is not going to be a solution. It's not going to give you guys a true statement. And that's how you actually check for solutions. You substitute the numbers, and if you get a true statement in inequality, then you guys will get you guys will have a solution for the x and the y for the inequality. So let's go ahead and start by doing that. Let's go ahead and check if we do have solutions for those inequalities. Let's see how to check if a order pair is a solution of an inequality. So here it says to determine if the order pairs are solutions. And I'm going to show you guys this example here. Notice that I'm giving you 2 points, and we just want to check if they are solutions of the inequality or not. So you're going to take the values of the x coordinates and the y coordinates. You're going to substitute into the inequality, and you have to check if the inequality is true or false. If it's true, then you say it's a solution. If it's false, we say it's not a solution. So I'm going to check the first point. My first point will be 2, 3, and I'm just going to label my x and my y, and I'm going to substitute. Here's the inequality, 2 times my x, so I substitute the x here, minus 3 times the y, and I substitute the y, and it has to be less than or equal to 1. So we do the math, we simplify, so that's going to be 4 minus 9 is less than or equal to 1, so negative 5 is less than or equal to 1. So we say this inequality, negative 5 is less than or equal to 1, is true. Negative 5 is less than positive numbers. Negatives are less than the positives. So since this statement is true, we can say that 2, 3 is a solution. It is part of the shaded area. The second point, we have 5 and negative 2. I'm going to label my x and my y. There's the x and the y. And I do the same thing. I'm going to use the same inequality. I'm checking this inequality for this point. So I want to see if it's true or false when I substitute. And I'm going to multiply 2 times the 5, which is the x coordinate. And I have minus 3 times negative 2, which is the y coordinate. And that has to be less than or equal to positive 1. We simplify, so this will be 10. Be careful with the signs here. We have a negative, minus 3 times a negative 2. Negative times a negative. That's going to be a positive. 6 is less than or equal to 1. So we get 16 less than or equal to 1. And that is false. 16 is not less than 1. So I'm going to write false here. And since it's false, we say that this is not a solution. So what it means is, when you graph, you will have a shaded part, and this point, 5, negative 2, is not on the shaded part. It's going to be on the other side of the line. And right now, I'm just using one variable. We have x is greater than negative 2, and we have y is less than or equal to 5. Now, you have to remember what to do when you have to graph a line where there's no y, there's only an x. So just remember, this x by itself is going to be vertical. So you guys will have a vertical line crossing the negative 2 on the x-axis. You also have to check your inequality. Your inequality greater than, there's no line on the bottom, tells you it's going to be a dash line. So I'm just going to put a dash here so you guys remember that we need a dash line, and you graph the line. So I'm going to go to the negative 2, which is right here on the x-axis, and I make a dash, vertical, going up, and going down. Okay, now, in order to know what side to shade, you are going to check 1 point. And I told you guys that if you get a true statement, yes, that's a solution, so you're going to shade that side. If it's a false statement, you're not going to shade that solution. Now, you can pick any point. But this is point to check is the origin. It's 0, 0 right here. So I'm going to check the origin. And I'm just going to put check down here, 0, 0. But you guys remember that in this inequality, we don't have a y. So I'm just going to worry about the x. The x will be 0. So if I plug in 0 is greater than negative 2, well, think about it. Is 0 greater than negative 2? Yes, that is true. Since it's true, what it means, guys, look for the origin. The origin is right here. The line is on the left side of the origin. So since this is true, 0 is greater than negative 2, you're going to shade the origin. And since you're going to shade the origin, well, you're going to shade all the side of the origin. So I'm just going to shade all of this side right here. And that's your graph. You guys have the inequality. The next one, well, you guys have y by itself. There's no x. So that means that it's going to be vertical, not vertical, sorry, horizontal, because there's no x. So you go on the y-axis and you make an horizontal line at 5. That's your number. Y is less than or equal to 5. So we go to the 5 right here. 1, 2, 3, 4, 5. And look at the inequality. It has a little line on the bottom. So that's going to be solid. So I'm just going to write down the word solid here so we know what line we need. And you make horizontal line, solid line. Let me do that again. I didn't like it. And we need to check what side to shade. So to check, you use the origin. 0, 0. Once again, you can use any number, but the easiest one to check is the origin because anything that you multiply by 0 will be 0. So that's going to be a lot helpful. We don't have an x. So the only number I'm going to worry about is the y. So I plug in, substitute a 0 into the inequality, less than or equal to 5. Well, think about that, guys. Is 0 less than or equal to 5? Yes, that is true. So what it means, guys, you are going to shade where the origin is at, right here. 0 is less than or equal to 5. So you're going to shade the bottom. If it was false, let's say, no, this is not false, then you shade away from the origin. So the origin is on the bottom of the line, so you will shade away. But right now it's true. So you guys are going to shade all the bottom of the graph right here. All right, guys, so I'm going to conclude my video here. I'm going to make a second part for linear inequalities, so make sure you guys check out that video and make sure you practice, and I'll see you guys later.